Great. So last but not least, we have Enrico, and I think we will get some very interesting insights about mapping relational databases, if I read your thing correctly. After that, don't run away. As I said, we will have more, but you don't have to use your brain anymore. You have to use the rest of your body for that. The stage is yours, Enrico.
Yeah, okay, here we are. Okay, so I'm talking about the relationship between knowledge graph and databases and information systems in general, because I believe that when people talk about this connection, we are all fuzzy somehow. We all trust our intelligence in doing something meaningful. I know that Dave is very smart in doing this job. He's telling us since many years. I know that many of us try to do this, but it's still an art in a sense. There is no systematic way to go from one part to the other part. And we don't even understand what is our goal on the other side. So most likely we know what a database or information system is, but there are so many different ways to have a knowledge graph. So what is a knowledge graph? I hate this word. I'm old enough to remember before the first of the 2 winters I've lived, when there were semantic networks, and the light came with Phil Wood's paper, What's in a Link. So here we see just random links going here and there. So we have to pay a little bit attention of what is this object here. Sorry, what is this object here, okay? So, and also, what is the meaning of this connection? So do we mean that we build some metadata of the data? Do we want to get also data transfer? And how faithful is the knowledge graph with respect to the data? Can we actually rely on the knowledge graph itself and forget about the data? So all these questions have to be answered somehow. So my work in the last 15 years, so even though I come from, you see, I'm from academia, I'm the only speaker today from academia, and I'm using whiteboard, so that's, okay, so I skipped the seat, okay. And my talk is only about an example, a large example. And because I'm a professor, I want to involve you now. So you see this table. Okay, study a little bit. I have a number of attributes. There are SSN, name, phone, email, department, manager. Sounds pretty reasonable. How many classes do you see here? We have one table. Okay, if I apply R2RML, I get only one class. Okay, oh. I don't even know what, so there was a talk today, all these are old observations. Well, these are not real observations. There is some semantics in it that as artists of knowledge, of semantics, we can actually take from this. But, so what is your take here? How many classes do we see here? Something like person. We were talking about persons. I take the first class I tell you is person. We have 4 persons, I would believe, here, right? What else we have? Contact. Sorry? Contact information. Well, okay, yes, that's okay. This is not really, these are just values, okay. But yeah, let's say there are names, there are phones, emails. Yes, these are. Sorry? Departments. We have departments also here. DEPT. Departments. Okay, we have departments. Okay. That's interesting. We have departments. In fact, they have different identifiers, right? So department is another meaningful class. There are at least other 2 very meaningful classes here. I see among all the persons, some of them are employees, because not all of them work in a department. And only some of them are managers. Okay, so I see person, employees, managers, and department. Then, of course, I see value types. Value types are classes, but which have identifiers, which have its own value. So emails and phones and names are value types. They're not entity types. So this really means that this database is meaningless if I don't attach some constraints in it. In fact, a database is always tables and some information, the schema of this, right? In fact, we always say RDF is a schema-less language. But then we struggle. We have to have at least an RDFS or some more information about it. So schemas are important. In fact, we tend to get it back. You start with RDF, and then we try to understand back what is the schema that we don't have in RDF. So in a relational database, the schema is called a bunch of constraints. And the typical constraints we have are functional dependencies like this. This means that if I give you an SSN, a phone, an email, I uniquely identify the name, the department, and the manager. So this really means that SSN, phone, and email are a primary key of this table, okay? Which is bizarre, because typically primary keys are the entity identifiers, but they are not, because what is this, right? So this means that this table does not really identify anything meaningful semantically. The second thing says that SSN uniquely identify a name and a department. So if I give you a person, because SSN clearly, at least informally, we are in the art area here, right? As an artist of semantics, I understand that SSN identify person, and then if I give you a person, I uniquely understand its name and where it works, given this data, for sure. Then I have what are called multi-value dependencies. These are set values function dependencies. So if I give you an SSN, there may be more, at least one phone and maybe more, at least one email and maybe more, okay? And these multi-value dependencies are these things that allow you to say that, okay, why Mary appears 4 times in this table? Because she has 2 phones and 2 emails, and you have to write all the combinations to be correct, right? So, and this is just wasting a lot of time in our art. And then there is a genuine dependency here, a functional dependency, which is, well, if you give me the department, I uniquely understand what is the manager of the department. In fact, there is a lot of redundant information here. D1 has SSN3 as the manager of the department, repeated 4 times, 5 times, okay? Because there are so many people working in D1, but not only that, because Mary appears 4 times. So it's a lot of redundant information. Now, there is another dependency, which all the managers, that's the last one, all the managers are persons, okay? So I cannot have a manager which is not an element of the first column. And this is also conditional dependency. So this dependency holds only for employees, not for persons. So only if you have a not null department, then the manager of the department is a person. Otherwise, well, there is no manager. How can we even say that? Okay, so that's the schema of a relational database. Maybe you don't have it because, and that's the main issue of these silos that we have today, that companies are lazy in building databases. It's too expensive to start with a conceptual schema with a bunch of constraints, with a proper design of the database. They just write the tables. And maybe they denormalize it. I heard this many people here denormalize database, and then they put in production the normalized database, and the origin of the design is lost. So there's a nice denormalized database. Maybe you have no clue that this was the schema that generated this database. And what can you do? Well, I can recover somehow this schema. Nowadays, there's plenty of work coming from machine learning. Sebastian Link in New Zealand has a company, Data Viadotto, that basically induces these constraints from the schema, from the data, sorry. I have the database, and then, okay, maybe from this database I can learn, I can find a correlation that all managers are also SSN. Okay, so maybe this holds. Well, but that's not all. So, and then somehow you can recover these things, but still we are in databases, and the data is still there. So what I want to do is to recover the actual schema. Now this, on the right-hand side, is what I call the core conceptual schema. So it's like RDFS without the data. So it's the actual conceptual schema without data that says, well, these are all the classes and the properties that are in this particular database. And this is, well, if you are careful enough, you could do it yourself using your art, your experience, the fact that you know what you are talking about. Okay, it's not that hard in this case. You see, well, managers are employees and are persons, because basically what I follow is that managers are definitely persons, but then because of this not null, they're also employees, because employees are the ones that don't have any department associated to them. The art still remains because you have to understand which are the names of these classes. But the fact that these are the classes appearing in this database is just a fact. Okay. Then, of course, we know that in this database, there is the has-name relationship that every person has exactly one name. Not exactly about, so you see this small line here. We are using this ORM notation, which is the Microsoft Visual Studio notation for database design. But I could do this in ER or in UML, or in this case, in RDF with shackle. I will show you in a second. But OK, so basically this says, well, every person necessarily has a name, and every person has at most one name, so has exactly one name. In the case of phones, it's not anymore true. So phones has, this is a uniqueness constraint, it's called. So basically, I can have multiple phones, right? But at least one, there is this dot. Same for email. Then employee, every employee works necessarily in exactly one department. And every department has exactly one manager, OK? OK, so that's, it's easy to understand why this makes sense. These are old value types. So these are like classes whose instances then don't need to be a URIs, they're just literals, OK? OK, so we can understand that this is the schema. Now, what I want to convince you at the end of this talk is that this schema, I can get it automatically with a completely automatic procedure from the data and the schema of the database. OK, so if this is the core conceptual schema, because I'm in an RDF community here, it's easy to see, I hope, that this schema, which is in ORM, ER, UML, take your pick, is an RDFS schema. So you're saying for each property, well, for example, first of all, you have identifiers for entities. So persons and department have their own identifiers. And so these are the identifiers for persons and department. They are, well, person string, department string. Then you have all these properties here. They are those. They have domain and range are defined by the restrictions in this diagram, of course. And then, of course, you need to have some cardinalities that you can, for example, express in shackle. Without cardinalities, you don't go anywhere, because these are important for constraint checking to be sure that this is exactly the meaning you want to express, and in particular also because you don't want to populate your database with wrong data. OK. So if this is the RDFS schema, I can automatically, so now I have my RDFS schema, which corresponds to basically my database schema that includes not only the schema of the tables, but also all the constraints. And then I can start automatically generating all the triples. Of course, I use a sort of standard R2RML conversion for identifiers. So this is a URI for a person, which is a person. This person has SSN, which is this one. Then I have another person, which is this employee indeed. Then people have phones. Then there is, you see there are properties that hold between IRIs, because they hold between the object property, they hold between class and other class, and not between a class and a value type. OK, so the department D1 employs employee SSN2, and all this. So I can actually write that. And turns out that this is exactly the right thing to do. So any Spark query that I would do to this RDFS plus shack graph will give you exactly the same answers to the, that you would get from querying with SQL to the database. More than that, I can also do updates. Because if you really trust me, you should, because that's 15 years of research, PhD thesis, publications. This translation is what we say, it's a lossless translation. So there is a formal notion which is called information content, as this RDFS knowledge base has the same information content as this database here, that data plus schema, OK? So it's lossless in completely different sense. And I can get this transformation for free, because it's automatic. OK, so now I have this thing, but I want to show you with an example what we can do with that. So now we have our RDFS data. And I did not copy this, but I assume that you can somehow get it from the table itself. So suppose now I make this insertion. That's a sparkle insertion, right? I add the triple that SSN1 has another phone, right? Because SSN1 is this guy here. So has one phone, I add another phone. Okay, this transaction succeeds, right? I can add another phone. Why? Because phone has a multivariate dependency. I can have more than one phone, okay? But what if now I do this here? Can I add a name to SSN1? No, this transaction has to be rejected because there can only be one name. It's a function dependency. Okay. Can I insert now really? Now this is a whole transaction, right? So all this addition have to happen at the same time. So I can create a new person which has a name, which would be illegal if I just add a triple new person with a name, because I cannot add a person with a name without that person having also at least a phone, at least an email, and optionally a department. So I have to do that transaction. So this transaction succeeds, and indeed will add a new tuple about Linda. Notice that I did not write the manager of the department which employs Linda. Well, because we have, through the dependencies, we know that the manager of department number 2 is necessarily SSN4, okay? So this assertion, this insert is legal because automatically the system would infer that the manager has to be 4. Let's see, what about deletion? Can I delete this phone here? I can delete because if I delete that SSN2 has that phone, still Mary will have another phone. By the way, we are going to see in the next slide, but I want to ask you, if I delete that phone, if I do this transaction, what happens here? What is being deleted? Only 2 rows. Okay, good. I have to delete also this other row. Okay? Okay, what about deleting still a phone number, but now for SSN4, who actually has only one phone number. So this transaction will fail. Okay? So because I like to do proper things, not only I can show you that this, the core conceptual schema, it's exactly the lossless characterization of our original relational database, but I can also go back and forth easily from queries and updates in Spark into query and updates in SQL. So this guy here, the first update that succeeds, is meant to add a phone to the person SSN1, and automatically I generate this query update in SQL that adds a new tuple completely, okay, with this guy here. And similarly for this guy here, I insert also clearly department 2, which is not mentioned here. Here I mentioned the IRIs, the identifier for department 2. And I automatically, added the proper thing. Similar here, when I delete this, I delete the entire tuple that satisfies this particular condition, right? Okay. Okay. So what we have here, that's a summary. We have a database with constraints. And now I presented everything in RDF because you are RDF people. But what I did really, I did the SQL version of it, right? I cannot care less about RDF. Not true, sorry. I care a lot about RDF star. And so I automatically create an SQL version of the RDF you have seen. So all the unary and binary table, that's it, really unary and binary. This is called, by the way, 6 normal form in database theory. Of course, I have to create also all the constraints in this database that really characterize all the domain, range, and the cardinality constraint you have seen in RDFS. Now, I can prove, so I have this database, there are 2 relational databases. I can, well, first of all, starting from S, which is this database, I can create the new database with the constraints, okay, and automatically create all these views, these mappings, that basically relate. In SQL, the SQL views, standard, everything is implemented in Postgres. No line of Java, Python, whatever. It's just pure SQL. These views will automatically tell you, well, if I insert a tuple in T, automatically this tuple will be updated in S. And so when I query S, I will get that query, this answer with this additional tuple, and vice versa. If the source database is updated, automatically the target database is updated, and the future query will consider the tuple correctly. All the queries are going to be local, so it's not. I'm sorry, Benjamin. We are not doing virtual graphs. Everything is materialized for having just as efficient query answering as you wish, because it's just everything is local. The only cost is updated. We're going to show you in the next slide. So we call this lossless dynamic replication. Okay, so yeah, at the cost of replication in linear size, so the database, they have the same size, okay, they're not exploding in size. It's just you double the size, fair enough, maybe for Uniprot this could be an issue, I don't know. But then what you can do. Okay. Another thing I need to mention is the provably correct. So these are our 15 years of research to get to this point. So we can, just like SQL, that's my first lecture of databases to students, why SQL is cool? Because even Microsoft could not screw up SQL. Even SQL Server gives you the same answer as Oracle or DB2, right? Because it's just logic. It's just, there is a proof, there are theorems behind that. And the same here, so we can prove that we get a lossless version in the alphabet of the conceptual schema. So remember, what is the advantage here? Now I talk, I can query, I did not show example of queries, but you can imagine them. But I can query, update, and insert and delete using the conceptual schema, not anymore something which I don't understand. So that's the business vocabulary, all the things that we see in data pipeline, in ELT. You can basically start understanding what you're doing, because now you can see the data with other eyes at no cost. Okay, so advantages. So we have native queries at each end. So just you query a database. So, okay, in this picture, we can see this whole thing is just a unique database, which maintains the original tables, has new tables, just standard, create tables, right? Not just something views or things. So whatever query will be answered correctly by having the local constraints, right? Remember, all these databases have their own constraints. So there will be some consistency checking, integrity constraint checking. Okay, so I have queries at both ends, and the response time is just as if this were just the original data. I can have update with just instantaneous update, because they're local update. Now the propagation to the other one is the best we can do, theoretically, is I just propagate to the other database the tuples which have to be updated. But this involves some complex calculation that may take, I don't know, 1 order of magnitude than the few milliseconds that it takes normally to query answer. And of course, integrity is maintained at both sides in a native way, because the constraints are just local, okay? Supports standard transaction, because we did not change the way a database works. We're just using classical create table databases, and so we can have normal transactions. And so what is this? So what are we doing? As I was telling you, we add, once you give me this, I will create this database with create tables and constraints, and these 2 sets of views, okay? Which are really slightly more complex. So these are materialized views with constraints, and I generate triggers, of course, because SQL triggers, because I have to deal with the update propagations. And this is done all automatically. So there is a piece of code that will do all these things for you, okay? There will be some intervention, of course, because the names, if you have bizarre names in attributes, and how came up with the manager word, right? I don't know. So you have to, there is an interaction with the system that has to decide which is the name of classes and the name of relations. It's all implemented in SQL. Now, there are disadvantages. What I say is that the update, we're not really happy with the update because it's not really as fast as it. We don't know whether there is a faster way to do it, but the major issue is that, well, you probably understood, I'm a professor, we have a nice group that's spun out on topics, so our colleagues did the startup on topic. I found today that there's a former student of ours that works at BMW, which is here, she talked here before. So we are a large group, or we cannot really do these things by ourselves. So when I say there is this code, okay, please help me, okay? Anybody interested, or whatever, we have stuff, but it's not really as robust or serious as it could be to be given. So what is really the state here, you give me your database, we have a group meeting, and the next day we'll give you by hand the thing, okay, this is the SQL you have to add to your system. And it's probably correct, okay? But we don't have a push button technology so far. Okay, that's it. No, is it time?
Hello.
Hello.
I have a question which I've been wondering about for a very long time, and maybe you have the solution, or maybe you have some insights. On your second slide or so, you had this picture with a database on the left, and then the knowledge graph on the right, or something more semantic on the right. And so many problems, including the problems you talked about in your talk, come from that you have the database, not so nice database on the left, and the knowledge graph on the right. Also, you have these problems. 95% of the projects actually using RDF data also do it like this. They have their data in a database, and then they have a dump process or some process which produces the RDF data, which for Wikidata, for example, takes a whole week just to produce the dump and has all sorts of problems. And my question is, why not have this data in RDF or in a nice semantic format in the first place?
Should I really answer that?
Yes.
Okay, no, otherwise, okay, honest answer, no BS, like one would say, keep it in databases. So I don't really see the point of having RDF unless you are dealing with integration, which is the really strong point of RDF. So interoperability, integration, all the uniprot thing we saw, that's crucial. But if you are just an enterprise, having your own data, maybe you have 10 databases to integrate, fair enough, is not, but you own them, you own the meaning. I don't think RDF is going to help you much. Sorry. And SQL technology is very strong. I'm really advocating SQL here. You want to go RDF, well, you do everything in SQL, and then you export it. So you exported this into that. That's just one-to-one. That's trivial, right? Everybody can do that. But yeah, is this a satisfactory answer?
Microphone is, I think it's wrong, right? Why can't you, can you elaborate on that in 2 more sentences? You're saying you should have your data originally in databases. You should not have it in RDF because there is some inherent shortcoming in RDF.
Well, that's a shortcoming. You need SHACL, OWL, you need a lot of technology to replicate something which is very fast in SQL. That's a fact.
Can you say that again? What's the point?
That in order to capture correctly all the semantics of data, you need to go beyond RDFS, right? You need to capture cardinalities, potentially a huge number. Potentially, you should go up to OWL or whatever. And this can be very expensive. And you don't need this power because what you only need is to have data and constraints. You don't need to reason over RDFS and SHACL and OWL. You need just to check the integrity of your data, if this is your goal. If you want to design your information system, then yes, you need to have reasoning. You have to check that your ontology makes sense, the implication of your ontology, whether it does not capture things you don't want to capture, and so on and so forth. Safety constraints, liveliness constraints, but...
So RDF and reasoning are two different things. You can have reasoning on top of RDF, but you can have RDF without reasoning.
Okay, now I understand your question.
Yeah.
Having RDF alone is just like having this table alone.
Yeah, exactly. You have this table, but you don't start with this table. You start with proper RDF triples. You think a bit about a schema, and you save yourself a lot of work.
Yes, okay, but in my experience, 90% of the projects that do things in this way, they end up with schemas that are just not capturing the fact. And for sure, you cannot do update. So if you want to have the guarantee that your schema is exactly the lossless version of your data, it's not because you have to follow my methodology. It's because this schema, the core conceptual schema, is the only ontology that captures that data. It's just that. I do not emphasize this enough. So this database, in the intended meaning, which is this one, remember there is this meaning that is crucial, because if you just give me this table, what can I say? Nothing. Anything can happen from this table. You have to tell me what are the constraints over the data, otherwise I cannot understand what you actually meant with that. So the notion of constraint is crucial in all this work. That's why we had the semantic web stack. People, if you just use RDF, there's a not nice idea of IRIs and integration and stuff, which I mentioned before. So for integration interoperability, that's cool. But just for data, it would be pointless to me. Don't kill me.
No, definitely not. I actually wanted to ask, how often do you run into the sad cases where all the constraints are not even in the database, but in the
100% of the time.
Programs around the database?
There are no constraints in any database that I've ever seen from companies. This exercise is where you really have, inducing these constraints is the real art of reverse engineering in a sense. It's not even an art, because nowadays we have a lot of tools to support this, which are all these machine learning tools that induce correlations. And then, of course, humans have to double check, is this correlation by accident? Is a causation? Is an inclusion dependency? So humans play a big role here to understand the domain. And I mean, Juan Sequeda has this wonderful methodology on how to go to companies and try to understand what is the meaning of the data, why the structure in this way. You have to talk with the people that actually write queries, to managers, to the only person that actually cares about the data. So yes, this process is very complex. It's because people did not start with this. I mean, I teach databases second year bachelor. I tell them, you have to start from there, and then nobody does it. Like, what can we do? There are these silos, and we have to revert them back. And what I'm suggesting here, because all my students were crazy, with the exception of one today, now we have to do this, yes.
So not a question, but my experience is that understanding real-world databases, it's almost like archaeology. You have to find people in the organization who have had something to do with that, and they will tell you, oh, we don't use that column anymore. There's this other column over here. And,
exactly, yes.
And you run a lot of these select distinct something queries to understand the ranges and things like that.
Typically, something that people don't do in reverse engineering, but something very useful, is to look at the code, the legacy code that access the data, and see which kind of query is this code. And then, well, why they did this query? And you look at the code, because they want to access this department, whatever. Okay, so this means this is a department, and so on and so forth. It's this art, yes. And, but what I'm proposing here is that this art should not leave the realm of relational databases. So this art should be used to find these things. Because if you, from looking at a database, try immediately to understand the schema, the conceptual schema, you may be wrong. This is too much appealing. So, okay, look, I found a manager. Okay, what is the problem? Okay, I don't know, whatever. So it's too dangerous to go there because you have no guarantee that whatever you have there is exactly reflecting this. By following this path, you are guaranteed that you do the right thing.
Good. Can we take this offline to relieve the
Dave. Come on.
Okay, Dave. Okay, you're right. Okay, Dave, I give you that.
So I'm not going to buy the don't start with RDF argument, but let me go back just to what you've done, which I think is pretty interesting. You're trying to deduce the constraint rules from a denormalized table. But then when you finally got to your sixth normal form, which looks like triples to us,
yes,
you then said, gee, I think is what you said, I could either update the normalized sixth normal form and project up to my denormalized, or I could update my denormalized and project back, right? Is that essentially what you're saying?
Yes, yeah.
I agree with all of that, except once you come to that conclusion, why don't you stop updating the denormalized one? I mean, what's the point of that?
Okay. So there are two reasons. Well, let me show you this picture, which I like a lot. If you look at it, the modern data stack,
I think
right?
once you get to that point, you realize the denormalized one is just a projection. It's just a view. In fact, I think you've invented a way to have updatable views, but like,
Okay, okay. If you go and look inside the pipeline, okay, you see that if I have my database, I'm proposing, okay, instead of going to the next step of your pipeline with that data, with that structure, immediately give let's say, the conceptualized version of it, right? So if the next step in the pipeline is data cleaning, you probably need to go back and fix the original data if you are the owner of the data. If not, then you don't do it.
Yes.
I'm just giving this possibility, right? So also the manager says, look, this is impossible, and proposes in the approval chain, look, this guy cannot have 2 children, right, but only 1. So he proposed this thing, and automatically there is an SQL query that then the database manager can approve to modify the original source. So potentially it's useful, depends on this idea has several scenarios, and actually the original scenario, which I modified for you guys here, is really the modern data stack. So to have the ability to, at any possible step, to understand what you are doing. So your data is always structured in a conceptual way, in a effortless. So it's not adding any time or space constraint to your work. That's a very strong statement, but yeah, we are all dreamers here, right? I guess.